So here we go again with a new rocket motor build video. You guys might know that I already completed motor testing, and that motor was good enough for the rocket and produced around 6 kilograms of thrust. But I want more altitude, so I decided to make a new motor with some modifications. In this video, I will show you this new motor build, and we will test it at the end of this video. If you haven't seen the previous rocket motor video, then I recommend watching that first. Before starting, I want to make it clear that this video is not a tutorial, it's just a documentary. Is that clear? The motor design is similar to the previous design. I used a PVC pipe around 9 inches long and some small pieces of PVC and metal washers to make the nozzle and end cap. I would say this is one of the best PVC motor designs I have found on the internet. So I began the process by gluing 1-inch PVC pipe pieces inside the motor body. I scratched them a little to make the surface rough and then placed them inside the body tube. I used super glue to attach the pieces, not because it is stronger, but because the PVC cement turned into something weird and solid. Super glue worked just fine, but it flowed everywhere. After attaching those pieces, I glued 2 metal washers together, as you can see in the video, but this time the throat diameter is 8 millimeters. In the previous rocket motor, the throat diameter was 10 millimeters, so this is the first modification. I am using a smaller throat diameter for higher chamber pressure, and higher chamber pressure means more thrust. Reducing the throat can also make the motor explode, and the fact that I am using PVC as the motor body can make the situation worse, so I have to be very careful. It's not possible that just super glue will hold the pressure, so I had to make the nozzle much stronger. To do that, I marked some points on the motor body and made holes at those points using a drill. To mark a straight line on the motor body, I used the paper method and it worked very well. I drilled enough holes so the joint would stay strong during motor firing, and instead of using screws, I used clay adhesive or clay epoxy. While shaping the nozzle, the clay epoxy came out of all the holes I drilled, and in just a few hours, the clay epoxy became solid like rock. I hope you understand what I'm saying. Using clay epoxy is easy and fast, but it can't handle the heat of the rocket exhaust, and the clay may lose its shape. But I think the nozzle wouldn't burn too much because the motor only burns for 1 to 3 seconds. So I think the clay epoxy will survive. After shaping the clay with my fingers for a while, the nozzle was ready and it was looking very clean, but the small throat is scaring me. To make the liner, I used this cardboard tube, and I used a similar tube in the previous motor, and it worked very well. I cut it to around 18 centimeters, and now it's time to make the fuel. I wouldn't tell you much about the fuel because YouTube removed one of my fuel-related videos, and another one got age-restricted, so now I have to be careful. To make the fuel, I used potassium nitrate, sugar, and some iron oxide. I made around 200 grams of rocket candy fuel, and this time, the fuel ratio was 65 to 35. It's not similar to the previous motor, because I used a 60-40 fuel ratio. I added iron oxide because it helps the fuel ignite more easily. I added just a little bit of iron oxide, and it was not a fine powder, so I think the fuel might produce some sparks. Now it's time for cooking. But before that, let's look inside a rocket motor. After testing the motor, I cut it in half so I could understand and fix any problems inside the motor. This is the clay epoxy, and it is part of the end plug. These are the PVC pieces that are holding the metal washer. Below the epoxy and the PVC plug, you can see a metal washer, and it is there to seal the pressure. When I tested the motor, I saw some black smoke after the burn, and I thought it was because the PVC disc was burning inside the motor. But as you can see, everything looks fine. The fuel isn't in very good shape, and there are some bubble-like structures if you can see them. The liner puffed up in some spots, but it worked very well because there were no leaks around the liner, and it kept the heat inside, which is why the motor didn't fail. This is the nozzle part, and you can see the PVC plug and some white clay epoxy that I used to make the nozzle. If you remember, I told you that the clay epoxy would change its shape after firing, and you can see what I was talking about. Before firing, the clay nozzle shape was like a cone, and that extra space appeared after the test was completed. You can see that the larger washer is holding the smaller washer, and the seal is nearly perfect, but it's not the same on both sides. Now let me cook. I put the fuel mix in the pan and started cooking. This time, the fuel mix looked brown because of the iron oxide. While the fuel is getting ready, let me tell you a little incident. Just a year ago, I didn't have any knowledge about rocket fuel, and I was trying to make some rocket candy. It was not too much. I think it was around 50 grams of fuel. I don't know why, but I added a little bit of sulfur and started cooking. I I wasn't too careful, and somehow the fuel started burning in the pan. I was doing that in the kitchen, and there was smoke everywhere. I didn't get injured, and nothing caught fire in the kitchen. It's important to be careful while doing this stuff, or making rockets wouldn't be fun anymore. When the fuel was ready, I put all of it inside the liner and made a core in the fuel using a metal tube and 2 metal washers. I applied oil on the metal tube so it wouldn't get stuck in the fuel grain. The fuel grain was ready, but I would say that it is not perfect. If you look inside, you can see some voids in the fuel, and it is because of my mistake. I didn't compress the fuel enough, and that's why there are a few voids. Let's see what is going to happen. The fuel had a weight of 150 grams, and it was not flat from both ends, so I trimmed it from both sides. Putting the grain inside the body tube is not too hard, but I had to hit the motor from the back side, so the fuel grain could slide inside the motor by itself. To make the end cap, I first placed a PVC disc on top of the fuel grain, and after that I placed a metal washer on top of the PVC disc. That is where I made a mistake. If you look carefully, then you will notice that the metal washer is not perfectly sized, and that means there was a very thin gap between the washer and the motor body. This was going to create a problem, and you will see that in a few minutes. Now I placed a PVC piece and then drilled 3 holes and sealed the end with clay epoxy. Now the motor is fully ready, but before testing it, let's see how the fuel mix is burning. This is the leftover fuel, and it started burning very easily, and as I said, the iron oxide was not a fine powder. That's why there are sparks. This fuel is weird. There shouldn't be any residue, but I can see some white stuff. I didn't give this motor any name because I didn't have any ideas. And sorry for the low quality of the video. I didn't have much time for testing. Now let's ignite the motor and hope for the best. I thought that the motor was going to explode, but instead it leaked from the end cap. That shouldn't have happened, because the motor design was good enough to hold the pressure inside the motor. The problem was not in the motor design, the problem was inside my brain. As you remember, the metal washer in the end cap was not perfectly sized, so there was a very thin gap in the end cap. Have a look at where the motor leaked from. So it's clear that the leak happened due to the wrong-sized washer. The motor only made around 3 kilograms of thrust, and the test stand was damaged in the action, and now it will take a few $1,000,000 to repair it. Well, this motor failed, and I still don't know if the 8mm throat diameter will work or not. I think I will test one more motor, but I wouldn't upload that test. I will only upload a few short videos. Now, I will focus on testing the flight computer and the rocket launch stand. The rocket will go to the sky very soon, and I know you wouldn't like to miss that. So join me on this journey by subscribing to my channel. That's it for this video, and we will meet in the next video.
ठीक है